Hey everyone, Teacher Chang here, and today we're going to talk about circles and the common terms and definitions that you need to know about them. So let's go ahead and take a look at these. We're going to break them up into three different parts. The first part is going to be on lines. So we want to take a look at the different lines within our circles. So the different types of lines we have here is a chord, a secant, and a tangent. So let's go ahead and take a look at them one at a time. So again, we have a chord, a secant, and a tangent line. All right, what is a chord? Well, a chord is basically just a line segment, and that line segment has to connect 2 points on the circle. So if we take a look at this drawing on the left here, we have a line segment where the two endpoints are going to be 2 points on the circle. So here we have an example of a chord. A secant is basically a line that goes through the 2 points on a circle. So again, it's a straight line that intersects 2 points on the circle. So kind of like our chord here, except this time it has to go through these 2 points. And then we have our tangent line. Now our tangent line is a line that intersects the circle at only 1 point. And that point is called your point of tangency. So that 1 point is called the point of tangency. So it's just barely touching that circle. So if we take a look here, we have our point of tangency located right over here. And then we have a line that goes through that 1 point and just touches the edge of that circle. So again, that 1 point where it touches the line is called the point of tangency. Some may call it the tangent point. All right, so we could go ahead and take a look at what a line segment or a tangent segment might be as well. A tangent segment is basically where we have a segment as opposed to a line, but the segment, one of the endpoints of our segment, must be the point of tangency. So for example, if I draw a line here, the point of tangency has to be one of my endpoints. The other endpoint could be over here somewhere. So this is an example of a tangent segment. The only difference is that the point of tangency must be one of the endpoints. All right, so those are our lines. Then we have our angles. We have 3 types of angles that we can look at. We have our central angle, and our central angle is basically an angle that is being formed from the center of our circle. Let me fix this here. I meant to choose the highlighter. So again, a central angle is basically an angle whose vertex is going to be at the center of our circle. And we could see that right over here on the left. So we see that the center is this point in red, and then we have an angle that is formed, and that's going to be a central angle. Now this central angle happens to be an acute angle here. Now we could have an angle that is greater than 180 degrees, so we could technically have a central angle over here. All right, we also have an inscribed angle. An inscribed angle is basically an angle on the inside of our circle. So the word inscribed kind of sounds like the word inside. And therefore, with something like this, we have to have an angle whose vertex is going to be on that circle. So it's being formed by 2 chords whose vertex is on that circle. So if we take a look at this one here, we have a vertex on the circle, and the angle is being formed by two chords. Now remember, a chord are basically two segments whose endpoints are on the circle. So this is the angle being formed, and this would be an inscribed angle. A circumscribed angle is basically an angle on the outside. However, that angle must be created or formed by two tangents. And since it's on the outside, the vertex must be on the outside. So circumscribed means that it's going to be on the outside and it just touches the circle. So in this particular case, we have our vertex on the outside. And again, we have two tangent lines. And tangent lines means that it just touches the edge of our circle here. So this angle formed is going to be a circumscribed angle. Then we have our arcs. We have minor arcs, we have major arcs, and then we have intercepted arcs. The minor arc is something small, and therefore it's an arc whose measurements is less than 180 degrees. Since we know that a full circle is going to be 360 degrees, we could kind of tell if something is less than 180. So 180 would be right in the middle. So right over here we have our point A and our point B, and the arc in between them would be a minor arc. So this is going to be denoted as arc AB. So it's denoted with two letters here because it's a minor arc. But if we have a major arc, that's going to be an arc whose measurement is greater than 180 degrees. Well, if we have an arc that is greater than 180 degrees, then we have to denote it with 3 points. So we have our two endpoints from A to B, but we need a point somewhere in the middle to go ahead and show that we're talking about this major arc. So the arc that is greater than 180 degrees. So to denote a major arc, we have to have 3 letters, and in this case we could call it A, D, B. Because if you just named it arc AB, well, that means you're talking about the minor arc right over here. So make sure that you denote a major arc with 3 letters. Now, we talked about an arc that is less than 180. We have an arc that is greater than 180, which means we could also have an arc that is exactly 180 degrees. And if we have an arc that is exactly 180 degrees, then we're talking about a semicircle. So I'm going to go ahead and draw a sketch of a circle here. And a semicircle basically means it's a circle that goes through the center. So it's half of a circle. So I'm going to draw this diameter that goes through the center. Now I'm going to go ahead and call these points, this diameter, AB. Now my semicircle could be this top portion or this bottom portion. Now if I'm talking about the top portion, well, I want to go ahead and use a third point. I'll go ahead and call this C. So if I want this semicircle here, if I want to talk about this semicircle over here, then I need to go ahead and denote it with 3 letters, A, C, B. So just like a major arc, I have to denote a semicircle with 3 letters, because if I call it AB, well then I might be talking about this bottom portion here. So if I want to talk about the bottom portion, I need another point somewhere in the middle, let's say D, and then I could go ahead and say that the bottom half is going to be called ADB. Now of course you could go ahead and call it BDA or BCA, depending if you want the top or the bottom. But you have to have the two endpoints and some point in the middle. Now, an intercepted arc is an arc that is formed when two segments, lines, or rays intersect a circle. So these are basically arcs that are being formed. So it's an arc that is formed when we have two segments, lines, or rays. So if we take a look at our first example on the left, we have these two lines here, which happens to be secants. I'll go ahead and change this back to a pencil instead of a highlighter. So we have these two secants. And when we have these two secants, it kind of forms this angle that intersects two arcs here. Oops, let's bring that back. So the first arc that it intersects is AB. And then it also intersects this other arc, DE. So this is a pair of intercepted arcs. Below I have a couple more, and we have on the left two chords. And the two chords are also going to intercept a couple of arcs here. So if we take a look at it in terms of left and right, the two chords are going to intercept the two arcs AD and BC. So that's a pair of intercepted arcs. But we could also take a look at the ones at the top and the bottom. So it could intercept over here at AB and over here at DC. So AB and DC are also intercepted arcs. And then we have a secant and a tangent over here on the right. And the secant in this tangent is going to be intercepting a couple of arcs here. And the first arc is going to be AC. So we can see that first arc. And the second arc is being formed right over here, BC. Oops, let's change that back. So if we have a tangent and a secant, well, we can see that they're sharing that one point of tangency right here at point C. All right, so those are basically your terms and your definitions. And what you need to be able to do is to apply them or be able to identify them with different situations. And there's going to be multiple answers for a lot of these. So we're not going to do all of them. We're not going to list every single possibility, but we'll just do a few here. So here we have this circle with a bunch of lines and chords and secants and tangents, and it also creates these angles and arcs. Well, let's go ahead and see what we could find. So the center is going to be the center point C. So there's the center of our circle. Radii just is a plural for radius. So we have several different radiuses that we can talk about, or we can call it radii if we want to call it plural, a plural. So an example could be CA or AC. You could also have CD or DC or CF or FC and so forth. We also have our diameter. Our diameter must go through the center, and the diameter could be AD or DA, and we could see that right over here. A chord, we stated that it has to be 2 points on the circle and a segment that connects them. So AH could be a possibility. We could have several other ones such as FD or even HB. But we can't have something called CF. That's a common mistake because, well, C is not a point on the circle. We also have secants. And a secant is a segment or a line that goes through 2 points. So an example of a secant could be GK. So G to K could be an example here. So it's going through 2 points in the circle. Okay, I'm going to erase some of these annotations here so that we don't get mixed up with some of these other examples. A tangent is a line where we have a point of tangency, basically meaning that it touches the circle at only one point. And we could see that right over here with the line segment GE, or you could call it EG. And the point of tangency in this particular case would be at point F. So point F would be our point of tangency. A central angle means that we have to have the vertex being at the center of our circle. So at the center of our circle, we have this point here at C, and we're going to look for any angle where the vertex is at point C, such as this angle right over here. And that angle, if we were to name it, we have to name it with 3 letters. That's going to be called angle DCF or FCD. Now you could also name other angles like ACF or FCA, or you could even name the straight angle ACD, which is 180 degrees. An inscribed angle is where we have an angle whose vertex is going to be on the circle itself. So I find a point on the circle, and I see if it can create any angles here, which it does right over here, creates this angle right here. So that angle could be HAD or DAH. Now we also have FDA or ADF. Let's go ahead and erase some more of these annotations. Let's take a look at some other ones that we have here. A circumscribed angle. Now a circumscribed angle is an angle that is formed by 2 tangent lines. And if we take a look at our circle here, well, we only have 1 tangent line. Since we only have 1 tangent line, that means we don't have any circumscribed angles. So here, we only have 1 tangent line. Now the line KG or GK is not tangent. So a common mistake that some people might say is that a circumscribed circle is KGE or EGK, and that's not a circumscribed angle because it has to be formed by 2 tangent lines. We have minor arcs and we have major arcs, so we'll talk about that next. But in terms of the circumscribed angle, this is not applicable in this case. All right, a minor arc means an arc that is less than 180 degrees. So we could just pick any angle here or any arc that is less than 180. And this one's pretty obvious, arc AB. So let's go ahead and list that as a possibility. Now, a major arc, again, has to be denoted by 3 letters. Now, a major arc has to be greater than 180 degrees. So we could go ahead and say maybe this arc over here, we got A going through B, going through D, all the way to F. Now, I have options here in terms of how I named them. I know that my endpoints are A and F, but I need a point in the middle. So I could use either B or D. So I could call this ABF or ADF. So I'll go ahead and call it ABF. An intercepted arc is basically being formed when I go ahead and cross 2 segments or 2 lines or 2 rays. Let's go ahead and erase a couple of these annotations here, or all these annotations. And we could go ahead and look for some intersecting lines. And if I take a look at this line over here, KG, and let's do AE, well, we can see that one possible pair could be formed right over here. We have AH as an intercepted arc, and the other pair, or the other half of that pair, would be BD. So AH and BD. AH and BD would be a pair. Now, I could have used those same two lines and called another pair being AB and HD. I'll go ahead and highlight that out for you. So AB and HD could have been another one. There are some more intercepted arcs as well that we won't list. And then we have our semicircle. And once again, a semicircle, you have to be able to name it with three points. So I'm going to go ahead and erase these annotations. And again, what I'm going to do when I'm trying to figure out my semicircles, I'm going to look for that diameter, and that diameter is AD. And I could either name the upper portion here in green, or I could go ahead and name this bottom portion here in blue. Now, if I want to go ahead and name the upper portion, well, I could call it ABD. That's one possibility. And if I wanted to name the bottom portion, well, I have options, because I do know that my two endpoints are going to be A and D. That's the beginning and the end. And I just need a point in the middle. It could be H or it could be F. So I could call it AHD or AFD. So I'll go ahead and call it AHD. Okay, so that's basically your terms and definitions of a circle that you need to know, and I hope this helped out. If you have any questions, go ahead and leave a comment. Don't forget to give me a thumbs up if you liked it, and don't forget to subscribe. All right, good luck, enjoy, and have fun.